Welcome to Algebra 1, Unit 7, Lesson 4, solving multi-step equations. Our objective today is I will be able to solve multi-step inequalities with variables on one side. I'm Mr. Pi, and I work out of the Pearson Algebra 1, copyright 2009 edition. So let's get this math party started. Now, even though this says steps to solving equations here, we could replace this word equations with the word inequalities, because solving inequalities and solving an equation are basically the same, except the symbols are different. The first step is to use the distributive property to clear any parentheses. Step number 2 is going to be combine like terms on each side. We're not going to have to worry about step 3 in this video lesson because we're going to be working with variables on one side. Then you undo the addition or subtraction. Then you finally undo the multiplication or division. In example 1t, we're going to be using more than one step to solve an equation. We're told to solve the following and to graph the solution. I have these steps right here just to remind us of how to do this. In part A, we're given 5 plus 4b less than 21. We have to solve this. Remember, the inequality is the middle of the inequality you're solving. We have to get rid of the 5 first. Now, a lot of students want to try to subtract 4 from both sides here, and we're actually starting right here in step 4 from our steps. And we need to get rid of the 5. I've seen teachers do this where they box off the variable, and that's the number you're going to want to get rid of last. Here, so then we're going to need to subtract 5 from both sides. And in doing that, the 5's on the left effectively are eliminated. They become 0, leaving us with 4b less than 16. Now that the variable term is by itself, we can undo the multiplication by dividing each side by 4. The 4's on the left-hand side, they divide out, leaving us with the b now isolated. And b is less than 4 because 16 divided by 4 is 4. Now we need to make a graph. In previous lessons on solving inequalities, and that was primarily with one step, I made graphs already on the presentation. Here I'm going to show you how I do it if I don't have a pre-made number line. Typically I'll just put the 4 in the middle and put the open circle on the 4 because there's no equal sign there. And since it's less than 4, I'll just shade to the right. I won't even really worry about other numbers unless it gives me some specific directions. So that's how we would do that. That's how I do it to make it a little bit easier on myself. Moving on to example B. We're going to again be starting with this 4th step down here where it says to undo addition or subtraction. Now here's a really big place where kids make mistakes. Again, if we go and box off this variable, we want to include that sign. We really should include that sign, because that sign now, when I go to get rid of this 5, is going to make this a negative 9x. So I'm not going to be adding 5 to both sides. I'm really going to end up subtracting 5 from both sides. I don't really want to focus too much in on that. I want to focus on the sign of the number that I'm trying to get rid of. Now 5 take away 5 is 0, and we've eliminated that. I bring down my negative 9x. I bring down the greater than symbol. And on the right hand side I do this arithmetic. Negative 13 take away 5. Well, that gives us negative 18. Next, I should recognize that I have negative 9 times x, so I'm going to divide each side by negative 9. And on the left-hand side, the negative 9's divide out, leaving me with x isolated now. On the right-hand side, a negative divided by a negative is a positive, so that would be positive 2. Now here's the key thing. I divided each side by a negative, so I need to flip the inequality around. So the solution is x is less than 2. It's not x is greater than 2 because I had to flip the inequality around. So making a quick number line, put 2 in the middle, and since it's no equal in that inequality, it's going to be an open circle, meaning it's not a part of the solution. And then I'll darken in or bold the left-hand side of that because it's less than. So there we go. There's two-step inequalities that I solved. Here in example 2, we're going to do some real-world problem solving. And since we're going to be talking about problem solving, I want to come back to this idea of rise. We're going to rise up to this situation and do a good job at solving this problem. To rise up, we need to read the problem, illustrate the problem, solve the problem, and then explain the problem. Here it says the band is making a rectangular banner that is 20 feet long with trim around the edges. What are the possible widths the banner can be if there is 48 feet of trim? Now, as I was reading, I underlined some important things, and that's to me a part of the read. And also a part of the read is to write down the important information and the question. Now, we know the banner is 20 feet long. We're told that. And that would be the length of the banner. We know it's rectangular also. What are the possible widths? Now, that's my question. And we're going to see how that question is going to translate into an inequality and not an equation. And the other piece of information is that the banner is no more than 48 feet of trim. So there's going to be no more than 48 feet of trim. So we're told that the perimeter is 48 feet. Now, in my illustrate portion, I've already put a rectangle in there. And if we start labeling it, we know that it has a length of 20 feet. And then, this side would be 20 feet. And what we're solving for here is the width. So you definitely could, in your solve section, do a guess and check method to figure out what the possible widths would be. I'm going to be inclined to write it as an inequality using this perimeter formula. The perimeter is equal to 2 times the width plus 2 times the length. There's other ways to express that. Now, using the information and modifying a little bit so it's easier to solve for myself, the perimeter I'm going to put on the right-hand side, and I'm going to rewrite this real quick, that 2 times the width plus 2 times the length is equal to P. Now, the width is what we're trying to solve for, so we'll keep that 2 times W plus 2 times L, and in this case 2 times L would be 2 times 20, and then our perimeter is going to be 48. Now we don't use an equal sign here because there's not one acceptable width, and we know that because it asks what are the possible widths. If we put an equal sign in here, that'll give us the maximum width. What we have to figure is what inequality goes in here, and the perimeter with these widths is going to have to be less than or equal to how much trim we have. So this is the inequality that we need to solve. And I'll put that down here in our solve portion of rise. 2w plus 2 times 20 is less than or equal to 48. And this ultimately is a 2-step equation. It ends up being 3 steps because we have to do 2 times 20. So I'm going to simplify that 2 times 20 now. 2 times 20 is 40. And it has to be less than or equal to 48. Hopefully you know now that we should subtract 40 from both sides, leaving us 2w is less than or equal to 8. Finally, we divide each side by 2, and w, or the width, has to be less than or equal to 4. And now for the explain portion, the widths, or the width, not widths, but the width must be 4 feet or less. And that does address the question. What are the possible widths? Well, it has to be 4 feet or less. So there again, we see rise in a second video lesson. In example 3, we're going to be using the distributive property to solve inequalities. We're not told exactly what to do here, but you can conclude that the directions are going to be solve the inequalities. And for the first inequality, if we're related to these 5 steps here, use the distributive property to clear parentheses. That's the first thing that you should do, is use this distributive property to get rid of parentheses. Remember, when you distribute, you multiply. So here we'd have 4 times 6 to give 24. 4 times minus x gives us a minus 4. I bring down my less than symbol. And also on the right-hand side, and I forgot my x here, I have to bring down the 3x, and in front of that goes a plus sign, or behind that goes a plus sign. Step number 2 tells us to combine like terms on each side. Well, on the left-hand side, our like terms are 3x and minus 4x. 3x take away 4x. That gives us a negative 1x. Bring down the plus 24, less than 2. Next, I need to undo the addition here. That'd be the 4th step. We don't have variables on both sides, so we just worry about the 4th step, undoing the addition. So we'll do that by subtracting 24 from both sides. On the left-hand side, the 24s become 0. They cancel out. We're left with negative 1x on the left, and on the right-hand side, 2 take away 24 is negative 22. Finally, we have to divide or multiply each side by a negative 1. Because we don't want negative 1x, we just want 1x, so that gives us x. Remember here, because I divided each side by a negative, I have to turn the inequality around. A negative 22 divided by negative 1 is a positive 22. On the right-hand side, part B, we have 25 is greater than negative 2 times 2y plus 3.5. As we just did, we're going to first use the distributive property to clear parentheses. Negative 2 times 2y, that gives us negative 4y. And negative 2 times a positive 3.5 gives a negative 7. I bring down the greater than symbol, and I bring down the 25. We don't have any like terms to combine. We do not have variables on both sides, but we do have some subtraction to undo, so we're going to add 7 to both sides. 25 plus 7 is 32. Bring down the greater than symbol. On the right-hand side, remember these 7s, they cancel, bringing down the negative 4y. So I need to divide each side by negative 4. We're on the 5th step here, undoing multiplication. When dividing by negative 4, on the right, the negative 4's cancel out, leaving us y. I switch the inequality because I divide both sides by a negative, and on the left, 32 divided by negative 4 is negative 8. Inequalities are best understood if we turn them around so that the variable's on the left. So our final answer, really, the best way to express it would be y is greater than negative 8. And when we switch sides of an inequality, we do have to turn the inequality symbol around.